Alrighty, hello everybody. We're back, finding the possible rational roots, getting the rational roots, and writing the complete factorization, right? And we figured out, we looked at the signs, the signs here. They're all the same sign, right? All of the terms in the function have the same sign, meaning you're going to get negative roots only. Right? And I was talking about this last time. You can't get a positive number here, put it in for x with all of these terms being positive, and have it come out to 0. The only way to get that to happen is with negative numbers to put in for x. Alright, so factors of p, right? Let's do it here. Factors of p over the factors of q. Nice thing here about q, once again, is that its leading coefficient is 1, right? So we can go right into p over q here, right? Since the leading coefficient is 1. If the leading coefficient was 2 or 3 or something, then we'd have to, write out the numbers that go into p, the numbers that go into q, and then p over q. Now we're just going to write the numbers that go into 48, and we're just going to do the negative roots, like a negative 1, right? Negative 2. 48 here has a bunch, right? Negative 3 goes into 48. Negative 4 does. Negative 5 does not. Negative 6 does, right? Go into 48. Negative 7 does not. Negative 8 does. Right? And then there's, you got that pair there, right? Negative 6 and negative 8 multiply to 48. So now you can start matching them up here, right? Negative 4 with a negative 12, right? For a negative 48. And then negative 3 multiplied by negative 16. For a negative 48. Negative 2 and negative 24. For a positive 48. I think I said negative 48. I mean positive 48. And then negative 1 times negative 48. All right. So let me tighten this up here a little bit. Get it on one line, and there you go. Alright, these are your possible rational roots. Alright, now we go and find them, people. Let's go find these rational roots now. Do a synthetic, right? 1 for your x4, 11 for your x3, 44 for your x2, 76 for your x, 48 for your constant. Right, there's no gaps here, x4 to x3 to x2 to x1 to 48, and here we go. All right, let me test, negative 1. Let's go back to my old standard ways here. All right, bring down the 1. 1 times negative 1 for negative 1 added to 11 is 10 times negative 1 is negative 10. 44 minus 10, 34 times negative 1 is negative 34. 76 minus 34 is 42 times negative 1 is negative 42, so no. Not a root. Negative 1 is not. All right, I'll try negative 2. I'm probably just going to go in order here. You should get one early on, and I think I said that, last time. When I say early on, with one of the first possible, few possible rational roots that you wrote. All right, we'll try negative 2. All right, 1 times negative 2 for negative 2. 11 minus 2 is 9 times negative 2 is negative 48. 44 minus 18 here is 26. Once again, make sure your computational work is good here. 26 times negative 2 is negative 52. 76 minus 52 is 24. This is looking good here. Times negative 2, excuse me, is negative 48, right? Add that, and there we go. 0 remainder. That's good, people, right? Negative 2 is one of the roots. And remember, we're going to use the numbers in the last line here, right? That's what I like to do, chip away at this. All right, to get this down to a quadratic, I like to take the guessing out of this. 1, 9, 26, 24. All right. Do you want to try negative 2 again? You can. Like I said, you don't necessarily have to do it the way I'm doing it here. You could try negative 12 first, you could try negative 6 first. But like I said, usually you get a root early on. It should happen with one of the, first few possible rational roots. You should get a root. All right, so I'm going to skip over the checking of the double root here of negative 2, and I don't even know if negative 2 is a double root. We'll see. If it is, it'll come out, it'll come out with the factoring, the negative 2. And so I'm going to bring down the 1, right? 1 times negative 3 is negative 3. 9 minus 3 is 6 here, so I'm trying negative 3. 6 times negative 3 is negative 18. 26 minus 18 is 8 times negative 3. All right, here we go. All right, minus 24 here. Added 0 remainder. Negative 3 is a root. Look at that. All right, so this is good because now this quotient here is a quadratic, Remainder is 0. Constant is 8. 6 is your x1 coefficient. 1 is your x2 coefficient. All right, so x squared plus 6x plus 8 equals 0. All right, factor, right? Factors of 8 that add up to 6, right? Or you could technically do a grouping here, and I think I've talked about that this year. Do a grouping. Right. two numbers that add up to the middle, right, and multiplied to the product of the first and the last number. You know, if you want to treat this like a grouping, you can. Right? Two numbers that add up to 6 and multiply to 8 would be positive 4, positive 2, right? So if you want to expand this, and that's what you're doing with grouping, is expanding the middle term, you can write this as x squared plus 2x plus 4x, or plus 4x plus 2x plus 8 equals 0. By the way, we're on page 23. You know, a little late in the game for that, but I figured you knew that. Doesn't matter the order that you write the 2x and the 4x. You know, you could do plus 4x first and plus 2x second there. So, and like I said, you can treat this as a grouping if you want, right? Factor out x here. X plus 2, this would be, what, a positive 4, right? To get the remaining factor here to be x plus 2, you know? And there you go. Technically, you factor out an x plus 2, and your other factor here is going to be x plus 4. So it looks like negative 2 is a double root, right? With that x plus 2 factor. What do I want to do here? I want to write the factorization now, right? Since I got x plus 2 and x plus 4. Just trying to figure out where to put this. All right, so the factorization I want to do over here. All right, so f of x, so the complete factorization now, once again, I'm just rewriting the original function in factored form. So I'm going to take the x plus 2 and the x plus 4 here from that, from that factoring that I just did. X plus 2 times x plus 4. And then negative 3 is a root, meaning x plus 3 is the factor that led to that root. So it's going to be times x plus 3. And then we had that negative 2 from the synthetic, right, to work, meaning x plus 2 is the factor that got that root. Meaning negative 2 is a double root, right? So x plus 2 here I'm going to write is squared. And that is factorization. Once again, just rewriting the original function in factored form. And now we write the roots. All right. So negative 2 here. And once again, you may see this on a multiple choice when negative 2 is a double root or whatever. They'll say M2, multiplicity 2. All right. And then negative 4 and then negative 3 are your roots. And there you go. Right, there you go, people. So, really nothing new here. This question is just now when you do these big questions, look at the original function and see if you have all of the terms having the same sign, or have alternating signs. You can cut down on your guessing, right? By, if you spot that out. So, all right. All right, I just want to mention this here. I'm not going to hold you responsible for it. This is really the last thing here for the unit. And I think I'm just going to talk about it very briefly, and then all of this here that's just like a practice. 14 and 15 or more practice on that, and then there's nothing new after that. So yeah, this is gonna be it. So so really what I just did there, that's what you are going to be responsible for. All right, so real quick, upper lower bound test, just to let you know what it is in case you're wondering. It helps out in the synthetic process, like in the question that we just did. You know, if you're doing a synthetic, right? And it says here, you know, if every number in the last line is positive, then that number that you tried out, you know, that root that you tested is called an upper bound. All right, it's called an upper bound. Now, what does that mean? Well, you know, think about it. It says here in number 10, prove that all of the real zeros of this function lie in the interval from -3 to 4. Right? So if your k value, your number, you know, that you test out for the synthetic is greater than or equal to 0, and you get all of the numbers in the last line of the synthetic to be positive, then k is an upper bound. So here they're saying, you know, show that 4 is an upper bound. You know, so when you do the synthetic, like I said, I'm just briefly talking about this. All right, just to show you. Now, we're not trying to show that there's a root here. All right, all of the numbers in the last line here are positive, right? Think about this, right? And think about what we were talking about, you know, back here, right? When they're, you know, these guys were all positive, you know, you're not going to get like 5 to be a root, you know, you're not going to get 6 to be a root here, right? You're not going to get a 0, right? It's the same idea here with, you know, by checking 4, okay, and getting all of the numbers in the last line to be positive, that just means there's going to be no roots to the right of 4. 5 is not going to be a root. 6 is not going to be a root. You know, any number to the right of 4 is not going to be a root. So that's why they call 4 here an upper bound. That's all it means. All right. No root is going to happen here to a number to the right of 4. And then, you know, if you try a negative number now, you know, like, you know, they say -3. They tell you the numbers to try here. It's not like you have to choose them. And then it says here for a lower bound, the number that you check out here is negative. And then if the numbers in the last line here alternate, okay, they say that, you know, this -3 here is a lower bound. All right. Meaning you're not going to have roots for this function to the left, all right, of -3. So this is a cubic function, right, number 10. So all it means here, you know, another way to look at it graphically, and then I'll wrap up here. For a cubic function, positive leading coefficient, all right, means once you prove something is an upper and a lower bound, all of the roots are going to fall between those two numbers that they give you. All right. So they're not roots. -3 and 4 are not roots. We're just saying that the roots fall between those two numbers by establishing, that, -3, let's say -3 is here. And it would be -3 comma -42 right there. And then, right here was, 4 comma 45. Your upper bound and your lower bound here. Right? So it means, once you establish that, -3 is a lower bound, it means that this graph is not going to come back up on the other side and intersect the x-axis. It's just going to keep on getting smaller and smaller as you go out to -infinity for x. When you do -4 for x, you're gonna get another number less than -42. Because of the alternating signs, in the last line here for the synthetic. So that's all it is, people. It just means it's not going to curve back up here to the left of -3 and intersect the x-axis. Same thing, with the upper bound. This cubic is not, it's not going to curve back down with an upper bound. It's just going to continue to get bigger and bigger and bigger. And once again, the reason that is because all of the numbers, in the last line here, the 2, the 5, and the 9 are all positive, right? Think about it. You put in, 5 for x, 6 for x, that y value is just going to get bigger and bigger and bigger, right? Remember, that is the y value there, the remainder. So there it is, people, all right? Like I said, I'm not even going to talk about the intermediate value property. If you want me to, you let me know. It's really not a big deal, but you're not going to be responsible, all right, for this page for your test. In addition, 13, you're definitely responsible for. 14, we did that. 15, you're not responsible for. 16 you are, 17 you are, and then starts the test prep. All right, so there it is, everybody. Unit